Hello and welcome. Today, we are going to do an experiment entitled, Determination of Molar Mass of a Volatile Liquid by Vapor Density Method. Vapor Density Method, or DO Mass Method, is an appropriate method to determine molecular weights of volatile organic substances that are liquids at room temperature. Mass method assumes that the gas behaves ideally. Incorporating the DO Mass method with the ideal gas law equation along with the equation of Antoine, the molar mass of a volatile liquid can be determined. Before we do the experiment, safety is a primary concern inside any chemistry laboratory. Hence, here are some safety precautions that must be observed. Always wear your laboratory gown, face mask, safety glasses and gloves. Drinking, eating, and smoking are strictly prohibited in the laboratory. Familiarize yourself with the facilities in the laboratory. Always remember, safety first. The objectives of this experiment are to estimate the molar mass of volatile liquids using the DO Mass method, to apply the ideal gas law equation through the measurement of vapor pressure, volume of the container, and the vapor temperature, to apply the Antoine equation to determine the vapor pressure at a particular temperature. The materials needed for the experiment are hot plate, 125 ml Erlenmeyer flask, 600 ml beaker, syringe, fine copper wire, aluminum foil, thermometer, reagent bottle, iron clamp, iron stand, cork, and lastly, the analytical balance. Prepare a clean and dry 125 ml Erlenmeyer flask as a container. Cut a piece of square aluminum foil. Cover the flask with the aluminum foil and secure it with a fine copper wire twisted tightly around the neck below the rim. Once prepared, weigh the empty flask using the analytical balance. Get a 3 to 4 milliliter sample from the reagent bottle using a syringe. Introduce the sample in the syringe by injecting the liquid inside the flask. Make sure not to enlarge the hole as it will introduce serious errors. Prepare the setup inside the fume hood to avoid inhalation. Bring the water bath to a gentle boil for about 10 minutes or until all the liquid has evaporated. Once all the liquid has evaporated, record the temperature reading. Remove the flask from the water and allow to cool down. When the flask has returned to room temperature and is completely dry outside, weigh it using the analytical balance. After the trial, rinse thoroughly the flask and fill the flask with water completely. Weigh it using the analytical balance. Finally, record the room temperature and the barometric pressure in the corresponding density of water. After the experiment, the following data should be recorded. Mass of empty flask. Mass of empty flask with aluminum foil and copper wire. Temperature of vapor. Mass of flask filled with water. Barometric pressure. And finally, the density of water. The data gathered can be treated using the following formula. After the data has been treated, here are the results of the experiment using ethanol, acetone, and ethyl acetate as the liquid samples. Again, in this experiment, the gas is assumed to behave ideally. However, in reality, there is no such thing as an ideal gas. Therefore, several sources of error will be encountered in this experiment. Notice that the moles of air was added to the moles of vapor in molar mass determination. This is because there is a presence of air inside the flask. Henceforth, the computed molar mass should be corrected via addition of moles of air to the moles of vapor.